project. So basically my topic is that I see that customers often struggle to select the right eyeglasses frame that suit their facial features on our app, leading to indecision, frustration, and lower conversion rates. The average time to purchase itself is 7 days, indicating significant friction in the product discovery and selection process. So my hypothesis is that the frame recommendation based on facial features using machine learning will increase conversion. Now, this is extremely attractive machine learning problem because there is a wealth of data available, including customer images, previous order data, product catalog attributes, and the post-purchase reviews, which tells us which frames are good on customer, looks good on customer, which customer likes, which can be leveraged to train robust machine learning models. Business impact, there is a business impact of these personalized recommendations can lead to higher conversion rates and customer satisfaction, directly impacting revenue and reducing time to purchase. Feasibility. So the advances in computer vision and recommendation systems make it highly feasible to extract these facial features and match them with frame attributes in real time. Hence, it is extremely feasible. So we have already discussed all these problems. Definitely, there is a problem. We see that in metrics like conversion rates. Yes, ML can definitely solve this. The recommendations and computer vision helps you get these facial features, right? And we have a wealth of data available, and definitely the people care and the business team care. Hence, from an opportunity evaluation point, all the three answers are on the good side. If you look at an opportunity evaluation metrics, it's a high business impact problem and with high feasibility because there's a wealth of data and models that has already been built on this. Now, from a business understanding standpoint, the target user is the user coming to app to find eyeglasses frame to purchase. Problem statement is that customers struggle to find these, leading to indecision and frustration. So there is a clear customer pain point that is there. It manifests itself in a low conversion rate. And again, that is why it matters. There's low conversion rate and low customer satisfaction. Currently, it is solved based on heuristics approach, wherein the recommendation based on popularity, occasion, and it lacks personalization to individual facial features. And I can see this as a gap in the current state. From a success metric point of view, again, business impact is clearly on the revenue. Identify constraints, so recommendations must be delivered in real time with minimal latency, and the process of collecting customer images and videos must be seamless and privacy compliant. These are the constraints. If you look at output metrics will be a matching score, probability that a recommended frame suits the customer face. So matching score based on the customer facial features and the frame and that frame attributes. And there is a recommendation latency also, that would be our output metric. It has to stay within a limit. And then there are output metrics like conversion rate, average time to purchase, and the customer satisfaction score, right? And these are our success metrics as well. As far as factors are concerned, so potentially relevant factors can be divided into 3 parts. Customer features, which is face shape, nose shapes, face size, nose size, gender, occasion for purchase. These are the customer features. Frame attributes, also the frame size, A and B heights of the frame, distance between lenses of the frame type, rimless, half frame, and full frame. These frame attributes are relevant features, and the behavioral data, previous purchases, ratings, and reviews data. These become our important data sets, and these are easily available from our database. Right? We will gather these from database. We can label this data based on the previous post-purchase reviews and ratings available with us, and we can also create features, basis finding the correlations with face shape, face size, frame type, nose shape, nose size, occasion, gender, etc. Right? Now, as far as solution validation plan is concerned, we can first start with building a prototype using heuristic model. A very simple heuristic model based on facial features to validate this concept and show the recommendation to the customer, highlighting that these are based on your facial features, and see the customer response to it. We can do a user testing to assess willingness to whether the user whether users are willing to share their images and videos to get recommendations during the onboarding journey. And once we have this, we can also do an A/B test between the current heuristic model and the heuristic model based on facial features to develop our baseline as well, right? And in this A/B testing, we can actually have a conversion rate as our primary metric. As far as ML system design is concerned, it can be a cloud-based architecture because there is always internet connectivity. Everything is happening on an app, which is supposedly connected to internet, and supports high throughput, scalability, and integration with our AR try-on feature, enabling robust data collection and low latency recommendations as well. So now, from a model training paradigm, since there is a lot of data, large data sets, high quality data sets across multiple databases, the training can be offline with periodic retraining as well, right? As far as real-time versus batch processing is concerned, we can do the batch processing of the predictions, because again, the requirements are real-time recommendations during user interaction. We need extremely low latency. So the potential risk in production is basically a training serving skew. We would be relying on a data collected from AR try-on, which may be of a higher quality than the images we may get during onboarding, leading to performance gap when the model is deployed. So there can be a concept drift. Customer preferences may shift due to changing fashion trends, altering the relationship between features and outcomes, like oversized frame fashion leading to people buying oversized frames can be an example of a concept drift. As far as data drift is concerned, there can be a data drift wherein the statistical properties of input data in production may change over time compared to the training data, such as shifts in customer demographics, image quality, even changes in the frame catalog updates, right? It can lead to data drift. While summarizing, I see a huge opportunity in terms of high business impact, clear feasibility, and clear customer pain point. Business understanding, we can clearly see there's a personalization gap and clear success metrics. From a data is concerned, we have a rich sources of data, and we need for quality and diversity is definitely there. We have to work on feature engineering. Validation is concerned, prototyping, user testing, A/B testing, everything is available for validation, so it can be validated before building the model itself. ML design can be it's a recommendation system, so cloud-based offline learning, batch processing, and extremely low latency system. Risk, we have